Dear students, good afternoon, everybody. We are studying the high voltage engineering. In the high voltage engineering, up till now, we have seen what is the breakdown in the gases. Similarly, we have seen the breakdown in the solid and liquid. So now, when this term high voltage is coming, it means that you are well known that the high voltage and high current are going to be generated. So in this unit, it is given how to generate high voltages and the high current. Firstly, we will see the generation of the high voltages. So in the last lecture, I have taught you taught you that how the high voltage is generated in the cascading form. Cascading is means it is not possible to erect or to manufacture a single generator with high capacity above, we can say about 400 kVA or 700 kVA. So in this case, what we are going to do? We are cascading this transformer, one transformer to second to third. So in this lecture, then we have seen the methods of the generation of the high voltages. Then in this case, we have seen that one point is going to be considered or one point is going to be mentioned, that is going to be the resonant transformer. So in this case, we will see what is the resonant transformer. The name itself suggests you. Name itself suggests you that what is going to happen in the case of resonant transformer. It means resonance is going to be off. You are studied in the third year, second year, what is the resonance? When the capacitance C is equal to inductance CL, then at this time the resonance occurs in the case of resonance circuit. So the same principle is going to be adopted in the case of this resonant transformer. There are two types: series resonance and a parallel resonance. So we will shortly see what is going to be happening in the case of series resonance and what is going to be happening in the parallel resonance. So firstly, we will see. Just I told you that resonant transformer runs on the principle that the load capacitance is variable, and for the certain loading, when the capacitance is equal to inductance of the circuit, resonance may occur. What is in this case variable? See the diagram, you see that. What is the variable? Capacitance C is variable. And for a certain loading of a loading capacitance is given as the load capacitance is given in this case. It means in this case, the load capacitance is variable, and for certain loading of that capacitance, what happens? The inductance is equal to capacitance. Under this current, always remember that under this current is very maximum, is very large, and it is only limited by the resistance of the circuit. The resistance of the circuit. The waveform of the voltage across the test object will be purely sinusoidal. You are knowing the different types of sinusoidal, rectangular. So it is going to be the sinusoidal purely. That is going to be obtained by the case of resonant circuit. There are two figures are given, figure number B and figure number C. Figure number B is for the series resonance and figure number C is for the parallel resonance. In figure B, see here figure B. Series resonance. What is going to be that? Reactor L is going to be used. See here. The inductance of the L reactor varied by its air gap. Inductance of the reactor. See here, the inductance is given variable and variable. It is going to be variable, but is variable in its air gap. By varying its air gap, and operating range is set in the ratio of 10 to 1 capacitance C. When it is going to be 1, 10, it is going to be 1. When inductance is capacitance is going to be 10, inductance is going to be 1. Comprise of capacitance of a test object. comprising of the capacitance of the test object, capacitance of the measuring voltage divider, and the capacitance of high voltage bushing unit. The Q factors obtained in this circuit will be typically CR of the order of 50. CR Q factor. What is the Q factor? You are well known with that one, going to be the Q factor, quality factor. Its value is going to 50, 100. What is the formula for that one? Can anybody tell me? What is the formula for the Q factor in this case? The Q factor is nothing but given by the formula that is going to be 1 upon omega CR. 1 upon omega CR. That's the quality factor. And its value is going to be so that Q factor 50. What is the one by Q factor 50? Means that voltage at the test object is 50 times the input voltage under resonant condition. Quality factor feet means that. Always remember, for voltage magnification, series resonance circuit is going to be used. For current magnification, parallel resonance circuit is going to be used. The Q factor obtained is typically CR of order of 50. It means there is going to be output is going to be 50 times greater than the input. And thus we are getting the high voltage in the case of resonance circuit. See the diagram. This is a variable reactor here. It is going to be untest variable such by the air gap. Here is the air gap. It is adjusted by that one. That is going to be that such adjusted that we are getting the C equals to L. And when the C equals to L, resonance occurs. And in the resonance, quality factor is given by the formula 1 upon omega CR. And from that one, you can say, suppose that 50 is going to be the quality factor, then you can say that the output voltage is 50 times greater than the input voltage. And this rating here, see there. Here is the regulator, rating is given. Regulator 10 to 100 kVA, excitation and transformer 10 to 100 kVA, output voltage of about 10 kV, reactor voltage each unit up to 300 kV. Here see the parallel resonance circuit as a test. High voltage reactor is connected as an auto transformer and circuit is connected at a parallel resonance circuit. See here, parallel resonance circuit. The advantage of parallel resonance circuit is that more stable output voltage can be obtained. More stable voltage output can be obtained along with the high rate of rise of test voltage and independent of degree of tuning and the Q factor. This is going to be the advantage. There is no problem of tuning, there is no problem of the quality factor. When we have seen the series resonance circuit, at this time I have told you what is the Q? Q is the quality factor. Suppose quality factor is 50, it means that in this case, the output voltage is 50 times greater than the input voltage. But in the case of resonance circuit, there is no problem of tuning. Here is the reactor, you see here. Here the reactor is used as an auto transformer. Reactor is used as an auto transformer. So this is going to be about the resonance circuit. In the next lecture, we will see what is the Tesla coil. What is the Tesla coil in the case of generation of the high voltage. So thank you everybody.